Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're gonna talk about Internet of Things or IoT devices. So let's dive right into it. Well, first we have to understand what exactly we are talking about. We are talking about basically the reality that we use a lot of stuff in our life, be it light bulb, be it refrigerator, water heater, microwave, or many more things, washing machine, things of that nature. So we use a lot of things. However, most of these things are quote unquote dumb. So basically they do not know when to turn on, they do not know when to turn off, they have no idea. Basically we have to control them. Now that's the whole point of Internet of Things devices. Basically all these devices, they work, they are real, they are absolute, they have been working for decades at this point in time, but they need a central agent, and most of the time is central agent is you at exactly on front of them. Basically microwave, you have to be there, water heater, you have to be at the switch turning it on and off, refrigerator, air conditioner, things of that nature. So the idea is basically allowing that central agent, basically be it you or be it some AI in a basically server, to take care of these things, basically creating a gap between. You don't have to be there, like it's like I got this. So you can have basically your air conditioner starts before you reach your house, so its house is in very comfortable position, and once you leave it will automatically turn it off. That's the whole point. So basically that central agent can become something else. Now, how we can achieve this magical feat of engineering? Well, reality is first you have to start with the basic. You have to have what we call data gathering system. Now, data gathering system will be directly proportional to what exactly you are making. For example, let's say you want to automate a water heater, or it will be completely different versus a light bulb that you want to automate. Because let's say for water heater, I just recently bought a water heater, so it has to have two sensors for absolute working. First, it has to see whether there is water or not, because if there is no water, do not turn it on. Like that's its first safety line. Second, it would be how hot it is, like what temperature, because again, if it detects, let's say outside temperature is not very let's say cold, but like it's a point where I would love 30 degrees Celsius water. It's like, okay, I'm gonna automatically adjust that. For that it needs a feedback loop, for that it needs temperature sensor. So that's the step of data gathering. Same will go with air conditioner. So first thing first, it has to do data gathering. And how the heck it does that? It has many sensors, be it camera, be it motion sensor, be it thermal sensors, be it whatever have you, like hundreds of sensors. You can be damn sure there is a sensor specifically built to track one specific things, including vibrations, including amperes, including how much water is flowing in a pipe using ultrasound. So there is a sensor for that. So that's the first step. You collect data. That's the step one. Then you have a processing and command center into that equipment. For example, I was recently that water heater I was buying. There was a other option that was quote unquote IoT, which had like Wi-Fi into it. So that, what does that mean? That simply means it has a microprocessor or a microchip where it's going to take care of things. Basically that's going to take the data and then it's going to process it, and then it can control it. So it's not just like, okay, look at me, that's my temperature, or it's not going to just broadcast something. It has the ability to control. That's the whole point, processing and controlling. And the reason why you have to process, basically everything reacts a bit differently. For example, a gas stove, if you set a thermometer exactly how you will set on a water heater, they're not going to work. A water heater is supposed to be below 100 and a gas stove has to be above 100. So you get the point. Like that's why you need processing and command center. So you need a bit of smarts, quote unquote, to work on it. And then the data coming from, like, once it has taken care of the data, once it has processed it, and once it has the authority to take care of things, it has to send that data to somewhere. Basically it requires a data network for transmission. Now on a cheap equipment it would generally be Wi-Fi. On a quality equipment it would be Wi-Fi and Ethernet. And then on a very high industrial proper reliable system, it will never be any wireless system. It will always be wired based. So it cannot be hijacked or tampered with unless somebody physically tampers with it. So that's the first requirement for data transmission. Now how the heck that data gets to where it's supposed to go, that's up to you. You could literally have a fiber connection in your home, you can have Ethernet to that equipment, you could have Wi-Fi hotspot. It's up to you. That's up to you. But that's what happens is, like, basically there has to be a way of handshaking and communicating data through and basically internet to you. That's what we call Internet of Things. So all the dumb devices in here, be it light bulb, gets connected to internet, and that's how we call it Internet of Things. This is not a person but a thing that is connected to internet. So that happens. And what happens after that? Now again, either you or server can be allow you to control it remotely. What does that mean? That simply means in your case it will be like your mobile phone is becoming a remote, or in case of generally Alexa or things of that nature, those are on server. So when you want to talk to Alexa, I'm coming home, so Alexa will know. It's like, okay, I have a lot of IoT devices connected about this house to myself. So it's like, okay, turn on the AC. Once he like he left the office, he told me like 30 minutes ago. Reaching home time is, let's say around 1 hour. hour, he knows the air condition takes at least 45 minutes to cool down, so it will trigger it, let's say, a bit early, let's say 50 minutes. So that's how my air conditioning will be completely completely worry free, cooling down. It's got the thing, I don't have to like go there and set it to minus 18 so it cools down quicker. Like, again, I know it's a human thing, but you get the point. So that's the whole point. You take a sensor, you observe the thing, then you have a command and processing center where you take care of the things, and then you transmit the data. Where the data goes, that's up to you. That's it's just on internet. How you deal with that, that's up to you. And sometimes people generally in very high end scenario, they do not want it to go to actual cloud, so the cloud is locally built. So there is a like actual server, small grade server is built there just to manage things. So that's how these puppies work. Now, what is the actual use of this super convoluted thing? Well, reality is it makes your life a bit easier, a bit more comfortable. For example, the air conditioning example is very obvious one. Another example would be basically thermostat that automatically adjusts. Basically, it feeds the data from weather satellites with everything else. It knows for a fact, let's say a cloud storm is coming, it knows for a fact the temperature will not change, but humidity will change. It can run the humidifier for much longer, knowing full well in advance that there will be a spike in humidity. Like all those things, it makes your life much more comfortable. It gives a feedback loop, and that's the critical aspect. For example, let's say you can have a water sensor on your basically a sink, which is in your kitchen, and it has a motion sensor in the kitchen where it's like, okay, motion sensor is active, that means somebody is in the kitchen and water is flowing, everything is awesome. Now people leave the kitchen, but water is still running. Now it will be like, okay, the sink is still running, but there is no body in the basically kitchen. Then it will send a alarm after set determined amount of time. That could be 1 minute, 5 minutes, up to you. So it will like send a message, and you ignore the message. It will like, dude, probably it's a leaking thing. Let's shut off the main valve. So make sure that there is no water supply in the kitchen. So that's why that feedback loop is very important. It's just not like, okay, turn it on or off. It's like, is something else that's supposed to happen is happening or not? For example, is there motion in the basically bathroom? If yes, only then turn on the water heater. That's the whole point. And it improves energy efficiency because you are only utilizing as much as you need. Now again, if somebody says like best way to energy efficiency, don't use that. But again, people are not gonna be there. Like, again, I can live without air conditioning for most of the time, but during summers, once the temperature start to reach 52 degrees Celsius, it gets very uncomfortable very quickly. Fundamentally, it becomes a unhealthy kind of temperature. So have to have that. So if I have to use it, might as well use it more efficiently. And then it can also have extra advantages where you can have timely service and repair. How the heck that can be achieved? Think of it this way. Let's say your smart internet of device, for example, air condition, it would have a data packed into it from day of its manufacturing. Once it was actually calibrated, it will be like, okay, if the outside temperature is 52 degrees Celsius and if the customer inside demanded 20 degrees Celsius, it should take you, if you have a correct power supply, it should take you around, let's say, 1 hour. Now again, air conditioner started to notice that it takes it 1 hour 30 minutes to achieve that. I'm like, okay, something may be off. Now it starts to take 1 hour 40 minutes. At that point, it will trigger alert. That means there is something wrong. It could be anything. It could be, let's say, the radiator side is clogged up with dust, so it's not able to dump the heat, or it could be like there is gas leaking, so you do not have enough refrigerant. Again, before it was too late, before your AC completely stopped working, your IoT device is like, bro, we got it. We have a situation. Let's take care of it before it becomes too bad of a situation. That's why that's an actual financial benefit, because rather than breaking your whole equipment, it will be like, I think it's an edge case where it's like reaching a point where it might break down. Let's take care of it before it does. That's the whole point. So there are a lot of use. Now, if you watch many videos of internet, I have provided them down below. The reality is very rosy glass. It's like awesome, everything is epic, everything is legendary. Reality is not that clear. Basically, fundamentally, all you are doing is giving up control for comfort. That's all you're doing. You are paying money, and you are also paying them control over your life. For example, let's say a company goes, I'm gonna cripple some individual. So how the heck they can do it? Let's say they sold you a refrigerator, and refrigerator is supposed to run for, let's say, 10 years. Normally, again, most refrigerators can easily exceed that, but 10, let's just go with that. Now, people do not have memory of like before 5 years. So they are like, once the refrigerator reaches the 6-year mark, the IoT device could be like, okay, I have crossed the 6-year point. That means the person can no longer recall when did he bought me. So it's like, okay, now I'm gonna break myself. So I'm slowly gonna trigger something weird, like how iPods had that, where the battery will self-destroy itself after 18 months. That was the first scam Apple did. So you get the point. So it could do something like that, and you will have no way of knowing. because again, it's not your brain, it's not an Excel sheet here where it's like, no, I bought this 5 years ago, so that means the product is defective, I'm not gonna buy from this company. It will be like, dude, I had this product, it worked for like, few years. That's what you will think, few years, and you're like, okay, I have to buy a new one. And you will have no way of knowing it because you gave the control to them. It's like they can break your equipment. And this exact thing happened with the audio equipment, where a company is like, you know what, if you I'm gonna disable a freaking audio amplifier, which should easily work for 10 to 30 years without any issue, unless some electrical malfunction happens. So instead of that happening, you have equipment that they can, quote unquote, brick remotely. You can't do anything because you gave your control for comfort. And complexity is the enemy of reliability. This is engineering principle 101. The more complex a system is, the more things that can break down, and the more likely it is to break itself. And I don't mean maliciously. It's just like, oh, there was this relay that was talking to this communication equipment, and boom, things fail. It happens. Like, that's why people want to remove system. Like, if you want to figure out how to make a system that never breaks, you make it as simple as possible. Complexity is the enemy of reliability. While you're taking something, let's say like a water heater that has been working for 100 years, and you are adding Wi-Fi to it, you are adding fancy LED lighting to it, you are adding fancy electrical relay which barely work for 10 years to that. You're basically taking something that could easily work for 20-30 years after a bit of minor repair and service, to something that you have to throw it away after 5 years. You did that. You willingly did that. And then it has more points of failure than we have thought. Like, everything that you see in your day-to-day life nowadays, it has been engineered the way after many years of research. Like, we had many faults, many accidents. Only then we learned, okay, like, that's how it's supposed to do it. That has not happened with Internet of Things. So we do not even know what kind of damage we can cause in tomorrow. Like, again, we don't have the data point because the equipments are new. And obsolescence would be a guaranteed thing, because again, same thing has started to happen with audio equipment. Your mobile phone is obsolete nowadays. Like, people used to have a phone, like my father's first phone that he bought was Samsung C100. It was like first slim, quote unquote, color phone, and it was like easily I would have used that for like, I think, 4 or 5 years. I can't do that with my normal system. Everything is becoming obsolete now. Obsolete in these sort of thing, I can manage that. But if my refrigerator started to become obsolete, I'm like, yeah, that's a problem. Water heater, microwave, things of that nature, that's a very big problem. And it makes you more vulnerable to everything. For example, it has happened in past where Internet of Things of device were hacked, and they were basically made into what we call pawns and bots, quote unquote, and they were started to call what we call DDoS attack, basically denial of service attack, because every house went from like having 1 or 2 computers to directly having 20-30 equipments. It was multiplied, like it overwhelmed Twitter. Like, this is a real thing, has happened. And you may not even know, like your smart fridge, it has a computer. Maybe somebody is mining Bitcoin on that. You do not know. So that's the whole point. It makes you vulnerable to so many things that is like, do you really need to have this? It's like, that's the whole thing. It's like you are giving control to someone else just for a little bit of comfort. Is it really worth it? Like, I have provided a video on, like, just look at it. It's like, yeah, it makes your life easier, but is it really that difficult to like get up and like, turn off a switch? Like, that's the whole point. So this was my presentation on Internet of Things. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me your disappointment. Please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.